Welcome back. Let us continue the exercise 5.1, in which the third example, area under the curve. So find the area of the region included between the two curves. Here y square is equal to 2x and y is equal to 2x as the two curves are given. So first of all, we must have the rough sketch of these two graphs. Y square is equal to 2x is the graph, is the parabola opening towards the positive direction of x-axis, and y is equal to 2x is this line passing through the origin. So the which cuts intersect each other at this origin and this point. We don't know the coordinates of these 2 points, and area between these two curves in the thing, but this is the shaded part. So here we must solve these two curves simultaneously to find their point of intersection. And how to find the point of intersection? We can put the value of 2x in the line's equation, or you can put the value of y is equal to 2x in this parabola equation. In anyhow you have to solve them simultaneously. So we get 4x square is equal to 2x. That means 2x into 2x minus 1 is equal to 0. So from this we get x is equal to 0 or x is equal to 1 upon 2. So these are the 2 points. So x is equal to 0 means y is equal to 0, and x is equal to 1 upon 2 means y is equal to 1. So these are the 2 points where this curve meets each other. Now here we cannot directly find this area. So first of all, whenever we choose this curve y from this parabola, you will be finding the area below the parabola. Means we are finding this area below this parabola, whole area. And there is one second case. uh, if you take a y of this line, then you will be able to find the area which lies below this line. So in either case we are not getting the required area. So what we have to do, we have to subtract this area below this line from the area which lies below this parabola. So in that case we will get this required area. Okay, so how one can do it? So let a1 be the area bounded by the parabola y square is equal to 2x, the x-axis, and the lines x is equal to 0 to x is equal to 1. Similarly, we will take this a2 is the area bounded by the line y is equal to 2x and the x-axis between the lines x is equal to 0 to x is equal to 1. So actual area is given by 0 to 1 by 2 root 2x dx minus 0 to 1 by 2 2x dx. This is for the parabola, y for upper curve minus y for lower curve. Take their integrations and put upper limit minus lower limit. After simplification, you will get 1 upon 12 square units. So this is the area of this shaded region is 1 upon 12 square units. Now the second one, the second example, y square is equal to 4x. Again, it is a parabola opening towards positive direction of x-axis. This is the line y is equal to x, which bisects the coordinate axis. Okay, so it will they intersect each other at 2 points. Now to find the point of contact, we have to solve these two equations simultaneously. So once you solve this equation simultaneously, you will get x is equal to 0 and x is equal to 4. But if y is equal to x, so again we will get y is equal to 0 and y is equal to 4. So these are the 2 points on this point of intersection of these two curves. Again, same as that of last example, a1 be the area bounded by the parabola and a2 be the area bounded by this line. So we will take the difference between these two. So obtain the area between the two curves. So 0 to 4 root 4x dx minus 0 to 4x dx. Take the respective integrals and then put the lower limit and upper limit. This root of 4 we can take as 2, and then root x means x raised to 1 upon 2. Its integral is given by x raised to 3 by 2 upon 3 by 2. So its reciprocal is 2 by 3 into x raised to 3 by 2. So the actual last value is 8 upon 3 square units. So area between these two curves, parabola and the straight line, is nothing but 8 upon 3 square units. Now the next example, again y is equal to x square, that is x square is equal to y. It is the parabola opening towards the positive direction of y axis, and the line is given y is equal to 4x. It's the line passing through origin only. So draw that line. So this is the area. Again, to find the point of contacts of, or from where to where we have to integrate, we don't know. So to find those points, we have to solve these two equations simultaneously. So you get x is equal to 0 or x is equal to 4. So put these two values in any one of this equation, you will obtain the y coordinates of y. So y is equal to 0 0. So the first point is 0 0 and the second point is 4 16. So y for the upper curve means y for this line, and y for the lower curve means y for this parabola. So take their subtractions, you will get the actual area. A is equal to 4 times integration of x is x square upon 2. Lower limit is 0, upper limit is 4, and integration of x square is x cube upon 3. Lower limit is 0 and upper limit is 4. So after putting the upper and lower limit is 0 0, so no problem it. So put the upper limit, so 4 square is 16 and 4 cube is 64. So 4 into 16 upon 2 and 64 upon 3 is nothing but 32 upon 3 square units. This is the area, this is the required area of this shaded region, or the area included between the two curves. Similarly, the next area is y square is equal to 4ax and the line y is equal to x. Again, it is a standard parabola open towards the positive direction of x-axis. So, and the line is y is equal to x. So, it bisects the coordinate axis. So, solve these two equations simultaneously, you will obtain the point of intersection of the two curves. Then, A1 is the area bounded by the parabola and the x-axis, and A2 is the area bounded by the line and the x-axis. So the required area is, we will subtract the area bounded by the line from the area bounded by the parabola. So after subtracting, you will get this equation. Then take the integration, x raised to 1 by 2, its integral is x raised to 3 by 2 upon 3 by 2. So 2 by 3 times x raised to 3 by 2. Lower limit, upper limit. X, its integral is x square upon 2. We can take 1 upon 2 common and x square, put x is equal to 0 and x is equal to 4a. So calculating it, the answer is 8a square upon 3 square units. This is the area. This is the area between the two curves. This is the general formula to obtain the area. You can replace this a by any number, then we will get the area of the corresponding uh, area between the two curves. Now the next problem is the y is equal to x square plus 3 and the line y is equal to x plus 3. Now if we want to, one can plot this line easily, because x is equal to 0, we get y is equal to 3. So 0 3 is the one point, and x is equal, y is equal to 0 means we get x is equal to minus 3. So the other point, so this is the point. So easily one can plot this line. But to plot this graph of this function y is equal to x square plus 3, it is somewhat difficult. It's not as much difficult, but one, if one is one can write this in a simplest form. So x minus 0 bracket square is equal to y minus 3. So it is in the form of x minus h bracket square is equal to y minus k. So you get the point vertex at 0 and 3. So this is the vertex. Now this parabola is of the form x square is equal to 4ay. So it is open towards the positive direction of y-axis. So this is the vertex 0 3, and it opens towards this positive direction of x-axis. So this is the area which we want to find, area between the parabola and the line. So use these two equations simultaneously and find their point of intersection. So you will get x is equal to 0 and x is equal to 1. After putting these values in any one of this equation, you will get the other coordinates. So a1 with the area bounded by the parabola. No, a1 is the area bounded by the line because it is upper curve, and a2 is the area bounded by the parabola because it is a lower curve. So we will subtract the area bounded by the parabola from the area bounded by the straight line. So use that values, use the limits, take the integration and put lower limit and upper limit in this formula. Then you will obtain the last step is 1 upon 6 square units. So this is the area, this area between this curve by y square, y is equal to x square plus 3, and the line y is equal to x plus 3. Between this area is 1 upon 6 square units. So this is all about the exercise, some problems from exercise 5.1. Now we will stop here.